When people think of airplanes, they picture enormous engines, giant wings, or a cabin packed with technology. Almost no one pays attention to the wheels. But at the most critical moment of the flight, the landing, they are the ones that receive the direct impact. A commercial jet can touch down at speeds of over 250 kilometers per hour and weigh hundreds of tons. All this energy needs to be absorbed in seconds, and the first point of contact is the tires. There is no improvisation in this part of the aircraft. Each wheel is designed to withstand extreme load, intense heat, and sudden changes in speed. They're not just big tires, they're certified components, laboratory tested and closely monitored by the airlines. If there's one part that can't fail at the most delicate moment of the flight, it's this one. And understanding how it works helps to see aviation in a new light. And to understand why these wheels are so special, we need to start at the point where everything really happens. The touch on the dance floor. The most demanding moment for the wheels happens at the exact second the plane touches the ground. The aircraft's wheels are not spinning before contact with the runway. They are practically standing still. When they touch the asphalt, they need to go from 0 to over 200 kilometers per hour almost instantly. This abrupt change creates enormous friction. That's why we see that white smoke during landing. Besides speed, there is weight. A large aircraft can land with more than 300 or 400 tons distributed over the landing gear. This impact is not just vertical. There are also horizontal forces caused by deceleration. Therefore, the wheels and the entire supporting structure are designed to absorb this load without deforming or losing stability. This is one of the most severe tests that any aircraft component faces on every flight. But then comes the question that many people ask. With all this weight and speed, why don't those tires explode? Now comes the technical part that really explains everything. Airplane tires are constructed in a completely different way from car tires. They have several internal layers of reinforcement made with high-strength synthetic materials, such as industrial nylon and aramid-type fibers. These layers form a rigid structure, capable of withstanding very high loads without tearing or deforming. It's not just thick rubber, it's applied structural engineering. Another important point is the internal pressure. While a typical car tire operates at between 30 and 35 psi, a commercial aircraft tire can operate at close to 200 psi. This means about 6 times more pressure. This high pressure keeps the tire's shape stable, even under extreme impact. In addition, these tires undergo rigorous certification testing, including high-speed landing and maximum load simulations. They are designed to withstand conditions far beyond normal use, precisely because the landing leaves no room for error. And there's one more detail that makes everything even safer, and that almost no one talks about. What do they put inside those tires? One detail that many people don't know is that airplane tires are not inflated with regular air. They are filled with dry nitrogen. The reason is not marketing or technical luxury, it's safety. The air we breathe contains oxygen and moisture. In a system that undergoes intense heating, especially due to braking after landing, the presence of oxygen and water vapor increases risks and internal pressure variations. Nitrogen is an inert and dry gas. It doesn't react easily, doesn't promote internal corrosion, and reduces the presence of moisture inside the tire. It's important to clarify that it also expands with heat like any gas. The difference is that without water vapor mixed in, this expansion is more predictable and controlled. In an environment where temperature and pressure change rapidly, predictability is key. Therefore, the use of nitrogen is standard in commercial aviation. Beauty? Now you understand resistance and control. But just looking closely at a large airplane raises another question. Why does it need so many wheels? If you look at a large parked airplane, you'll notice this. A Boeing 747, for example, uses 18 tires. The Antonov AN-225 used 32. This is not an exaggeration. It's a structural necessity. A large aircraft can land weighing more than 300 or 400 tons. If all that weight were concentrated on just a few wheels, the pressure on the track would be enormous, and the risk of structural damage would increase significantly. Distributing the weight across multiple wheels reduces the individual load each tire has to bear, and decreases the pressure exerted on the asphalt. This protects both the landing gear and the airport runway itself. In addition, multiple wheels increase stability during landing and braking. It's not just a matter of supporting weight, but of maintaining control and balance at high speed. And then comes another very common question. Why do people always think of the worst-case scenario? What if a wheel blows out right at the moment of landing? A tire blowout on an airplane is not a common occurrence, but it is a situation anticipated in the aircraft's design. The certification requires that the aircraft be able to land safely, even if one of the tires fails. This is possible because the weight doesn't depend on a single wheel. The load is distributed among several aircraft, and the landing gear is designed to withstand temporary impacts and imbalances. Furthermore, aircraft tires do not usually disintegrate like car tires do. They are reinforced to prevent explosive rupture. Even when there is damage, the structure of the assembly tends to maintain sufficient integrity until the aircraft comes to a complete stop. There are records of landings performed with damaged tires, where the aircraft maintains stability and control throughout the deceleration. Security is based on redundancy and planning, not luck. But the work of the wheels doesn't end with the playing. In fact, after landing, a part begins that's just as arduous as stopping the plane. After the initial contact on the track, another critical phase begins: deceleration. The wheels are not only for supporting the weight, they also help to stop the aircraft. Commercial aircraft use carbon brakes, a material capable of withstanding extremely high temperatures, often above 1,000 degrees Celsius. This is necessary because the energy involved in braking hundreds of tons at high speed is enormous, but the aircraft doesn't rely solely on its brakes. Immediately after landing, the spoilers deploy over the wings to reduce lift and transfer more weight to the wheels, increasing braking efficiency. At the same time, the thrust reversers direct some of the engine power forward, helping to reduce speed. It's a collaborative effort, with tires, brakes, wings, and engines working simultaneously to ensure that this gigantic mass comes to a safe stop within a few kilometers of track. And finally, there's an aspect that airlines know very well: cost and maintenance. Because all of this doesn't just work by replacing things when there's a problem. These tires aren't cheap, but they also don't cost absurd amounts, as many people imagine. On large commercial aircraft, a tire can cost close to several $1,000s, depending on the model and manufacturer. But the most interesting point is not the unit price, but the maintenance. Airplane tires can be retreaded multiple times. The casing is reused and receives a new tread, which reduces costs and maintains the required safety standard. The replacement isn't only done when the tire wears out. There are technical limits defined by inspection, landing cycles, and wear. The companies monitor each set with precision. Nothing is decided on the fly. Ultimately, those wheels that go almost unnoticed at the airport are among the most tested and controlled components of the aircraft. They are small compared to the entire plane, but they have a direct responsibility in every safe landing you've ever made. And thank you for watching until the end. Subscribe to the channel, leave a like, and turn on notifications so you don't miss the next videos.